Hello and welcome back to our data structures and algorithm series. In this video, we are going to learn about the queue data structure. I'm going to tell you what the queue data structure is. We're going to look at the properties of the queue data structure, the different operations that we can carry out on this data structure. We're also going to look at how to implement the queue data structure using a linked list and also using a list or an array, if you may call it. And lastly, we are going to look at the applications, the real-world applications of the queue data structure. Now, on this image that I have here, we have a typical queue where we have typical Kenyans lining up to voting their next leader. And as you might have imagined or guessed already, the lady in blue is at the front of the queue and therefore is going to be allowed to vote next. Then we also have the end of the queue, the lady with the Masai Shuka. And the end of the queue is called the rear, while the front of the queue is called the front. So let's dive in and look into the queue data structure, which is not very different from the queues that we make in real life. Now, the queue data structure is a linear data structure, meaning items will follow each other in a linear fashion, one after another. It follows the first in, first out principle. So again, just like on the previous slide, the lady in blue came before the lady with the Masai Shuka, and therefore she's going to vote really before that lady at the very back is allowed to vote. So first in, first out. Or first come, first served. So it's called the FIFO principle. Now the elements in a queue are added at the back of the queue, which is also known as the rear. So here the rear is here. So items, if we needed to add another item here, then we will add another item here at the back of the queue, at the rear. So the lady with the Masai Shuka will join at the back of the queue. You can think of it like that. Then when we want to remove items from the queue, when we want to serve, then we serve from the front of the queue, So let's move on. And just as a reminder, the queue data structure is a linear and dynamic data structure, as we can see right here. And it's actually the last linear and dynamic data structure that we're going to look into. In the next topic, we are going to cover nonlinear data structures, which includes the tree and also the graph data structure. So we're going to look at the tree and the graph. But remember that the queue is a non-primitive, linear, and dynamic data structure. Now, let's look into the different operations of a queue. We have two major ones, and we're going to look at three other basic ones. We have dequeue, which is actually deleting an item from the front of the queue. And we also have enqueue operation, which is actually inserting items at the back or rear of the queue. So if we can focus here and see how we dequeue. So to dequeue, we simply remove the item, and now the pointer for the front will point on the next item like that. Then let's visualize and see how we do the enqueue, how we add an item at the end of the queue. So if you focus on that, you can see that now we're adding an item, and we're also going to update that rear pointer so that now it's pointing to the last item there. The other operations of a queue include the pick operation, and as you might have guessed, just like in a stack, this is used to access the first element in the queue, which is the front of the queue, without really removing it. Then we have the is empty, which is used to check if the queue is empty, and we also have the is full operation, which checks if the queue is full. And this is only possible when you are implementing a fixed size queue. Most of the time when you're using a list to do so. So here we have a quiz for you. So try and jog your mind and see whether you're going to get it right. Okay. Now we have different types of queues. The first one is what we've been looking at. It's called a simple queue, also known as the linear queue. So it's just what we've been dealing with. And then we have a circular queue. With a circular queue, we have the rear pointing to the front of the queue. Therefore, it forms a circle, just like we can see in this particular image here. Then we have a priority queue. So with a priority queue, as you might have guessed already, we have values that are associated with certain priorities, and depending on whether the queue is an ascending priority queue or descending priority queue, then we are going to really have the item at the front being either the largest or the smallest. So for example here, the element with the highest priority is this 80, and you can see the next priority is 30, then 20, then 10, then so this is actually a descending priority queue. So it can also be the other way around. So we can have 5 here, and then 10, then 20, then 30, then 18. Then that will be an ascending priority queue. So with a priority queue, we're always going to dequeue or remove the item with the highest priority. And this is actually applied, especially in networking, when we want to implement different bandwidths for different priority packets. Then we have the double-ended queue. The double-ended queue. So with the double-ended queue, you can, I know this is not very clear, but you can actually enqueue or delete from either side. So that's what is called a double-ended queue, and it also has its own unique applications. So we can implement queues using arrays, and we can also implement queues using linked lists, just like the stacks. The advantages of using an array to implement a queue include the efficient enqueue and dequeue operation. So as you might have guessed, when you use a list, we already know the first item. So to remove it, or the last item to add a new item, is just an O of 1 operation. And of course, implementing using a list is always easy. The problem with using arrays or lists when we are talking of doing it in Python is, number one, memory wastage. So when we dequeue items, and sometimes if we don't have the initial size of the queue, then we might take up more space than we really need. So that ends up wasting memory. Also, there's a problem with resizing challenges in case we did not specify the size initially, and we are given, for example, a size of 5, and we need more spaces. So that will implement a very expensive operation, which is resizing, which is a bit expensive. With linked lists, the main advantage is that it's dynamic in size, so it's used to implement queues that do not really need you to know the size initially. Then we don't have any memory wastage, because we're just going to create a new node for every queue item that we create. Of course, it is slower when it comes to enqueue and dequeue operation, because that is an O of n operation. We have to traverse the list for example, in order to add an item at the very end of the linked list. And then, of course, implementing using linked list is normally a bit complex when it comes to writing that particular code. So another challenge for you, so give it a try. Okay, I hope you got it right. Okay, then we have the real world applications for real world application for queues. Number one is waiting lists. So anytime you're sending items to a single shared resource like a printer, so you're going to have a printing list, which is going to put the items you're sending to the printer one after another. So after one is done, then we process the next one that is at the front. Similarly, when it comes to operations that require the disk or the CPU, they're normally queued by the operating system. Queues are also used to implement breadth-first search algorithms. So when we learn this, you're going to understand this more, because they're used to explore the neighboring nodes level by level, the nodes that are next to each other. They also used to implement priority queues, which are used to prioritize elements based on their importance. So for example, I've told you in networking, we might have packets that have different priorities, and therefore those ones that have a higher priority are going to be processed faster. They're also used in real-time systems, especially in buffering the data so that it can handle data one after the other. Okay, so let's give this a try again. Okay, I hope you got that right. Okay, when it comes to time complexities, when you're using a list to implement the queue data structure, all the basic operations actually give you a time complexity of O of 1. Then, of course, for space complexity, it's just O of n, because it depends on the number of items that you're going to add on the queue. So it's O of n. When it comes to implementing that using a linked list, so this is using a linked list. We have two scenarios for enqueuing, which is adding items. It can be an O of 1. If you do not have any other node on the linked list, it's going to be O of 1. But worst case scenario, which is going to be the most, which is going to be this most occurring scenario. So you're going to traverse to the end of the list to add an item. So it's going to be O of n. Also for dequeuing, it can be O of 1 or O of n for the worst case scenario. For picking, just looking what is on the head of the list is O of 1, linked list that is. And for checking whether the linked list is empty, it's just an O of 1. We just check if the head is none or null. For linked list, we don't have the is full operation because we do not specify the size of the queue when you're using a linked list. We only do that when you're using an array or a list. For the space complexity, again, is just O of n. Okay, so let's give this a try. Great. I know you got that right. Okay, so that is it about the queue. So we've learned that a queue is a linear data structure that has a front and a rear, and that we only add items from the rear and remove items from the front of the queue. We've also learned that we have different types of queues, including the simple queues, the circular queues, the priority queues, and also the double-ended queues. You can perform different operations on a queue, including enqueuing, dequeuing, check the item at the front of the queue, which is called the pick operation. You can also check if the queue is empty, so it's empty, and also if the queue is full. We've seen that you can also implement queues using either a linked list or a list, which is an array really. And you can also and we've also seen the time complexities of implementing queue data structure using either a list or a linked list. So that is the end of this particular topic. In the next video, we are going to look at, we are going to implement these operations using a list, these queue operations using lists in Python. So thank you so much for sticking to the end. See you in the next video. Bye bye for now.